So here's a few common mistakes I saw yesterday. When I say common, I saw them more than one time. Derivative of t is non-zero. The derivative of e to a 2t, we don't just dump the t. When we have something like this, the 4 doesn't magically disappear and just make this 1. And when we do the cosine sign with the squared, we don't pull the 3 out and multiply it by the 4. That doesn't work either. Make sure when you're doing square of a term, it doesn't equal a squared minus b squared. It does equal a minus b times a minus b. And you have to FOIL it out. Some people we're pretty good at FOILing shit out because they FOILed this out rather than taking the just seeing that the square root and the square cancel. I saw some good people, or some people FOILing this out when it was complicated to FOIL out, but they did. Just make sure you're not making some of those common mistakes. All right, let's get back to this.
1 second. I mean, there's
And another way to write those notations is df dx and df dy, in case you did not watch this video. 13.3 is pretty important for the entire rest of the semester. Partial derivatives are the way to move forward for multivariable functions.
that's a D.
That is a
Different. It's a different.
it's a partial D.
Partial D.
I mean, I don't think it actually has a name. I asked this is Vanetta, I'm like, does that have a name? He's like, no, it's just a D. Like, okay. Yeah, it's very confusing. Makes it kind of confusing sometimes.
Backwards, upside down. It's a backwards 6.
I didn't think about that.
I think
It looks kind of like a backwards 6, yeah. It's a
It almost
fancy
looks like-
E.
That just looks like a limp D.
The hardest part of using, you'll get used to recognizing these as partial derivatives. The hardest part you'll see when you start using them is when you have something where the D changes in consecutive steps, like having df dx like that, and then dx dt where it's a pure derivative. The regular D implies x is a function of t only. The backwards 6 implies f is a function of x plus more stuff.
What is dx d1? What is that?
What the fuck is dx d1? You know that is not a 1. There's nothing that, if you think that's a 1, get out of my class right now. Or get glasses. I know, Lauren, I know you don't. Lauren, do not make me pull out your test and put it on the monitor.
Is it legal if I give you my permission?
It's legal if you give me your permission, yeah.
On the record, you have my permission. No. No.
On the record, I have your permission. Is that what you said? I can show you your test if you'd like.
I either like rabid dogs.
Lawrence did a really good job on the test. Lawrence got a good score on the test.
That's why.
It's like an example of like how to be careful. Yeah, there are a bunch of stuff like up there. Okay, yeah, just like kind of physical.
There were 3 perfect scores in the class. 3. 3, I mean, when I say perfect, I mean all the extra credit included.
Mm,
We gotta find this person.
Yes, Ben, you have another rival.
Oh my God. You've got two, so. Yes,
All right, so what is the partial derivative with respect to x?
Well, no, I meant the two people that you got BS anyway.
What is df dx?
Negative 2x. So negative 2x.
It's negative 2x. Derivative of a constant 0. And while we're taking the derivative of x as a partial derivative, y is treated as a constant. So there is no x in that term. This term goes to 0. With that in mind, the next one should be fairly easy. The 9 goes to 0. The negative x squared does not have a y in it, so it goes to 0. And negative 7y cubed goes to negative 21y squared. Now, when we evaluate at 3, 1, we just plug shit in. Negative 6
Notation, no.
and negative 21.
There you go, much better. I forgot the notation. I just watched the video.
This is similar to when you do the integration. This vertical bar thing, same thing as when you integrate. Like if you integrate a constant, you get t and you're evaluating from 0 to 3. Same type of notation. The book, and I do it in my lecture notes, they will also write another way of showing that is df dx with 3 comma 1 like that, which is helpful in the beginning, but it's got like gets a little confusing. And like we have up here, same thing up here. Any questions on that? All right, let's up your game. Oh shit, I smudged it a little bit. That's a Z.
I know, it's pretty E-ish.
Was what the fuck? I thought it was cheap.
You're really gonna stick with that, aren't you?
No, I actually legitimately thought that was a T this time.
Okay.
Look at these pocket glasses.
I was about to say, is that a 1? But then.
No, Lawrence, that's at the point T2.
So where does the team ranking stand at in the Mesa Center? Who's winning, James? Is it you or Ben?
I don't know, I haven't seen it. I heard about it though.
Ben told me he was winning, but the picture he sent me showed him not winning. And he never
Oh.
sent something showing otherwise, so I still don't know if I buy it.
Oh, you talking about the board. Oh.
What happened? It was on like on the Discord last night. Apparently someone like in the Mesa Center put like team Ben, team Lawrence, and team James on in the Mesa Center.
Nah, there
No,
wasn't.
Team Lawrence was my addition.
Oh, that was your edition. Okay. Man, I'm off the time zone.
I thought Lawrence deserved a team.
You guys even sleep, like jeez.
Well, I think maybe before I do dz dx, I'm going to rewrite z in a format that I like, which would be exponential notation. Because even though it takes up extra space to rewrite it, I'm less likely to make a mistake when I'm looking at that notation, because I can just do just a regular derivative with the chain rule.
Oh.
And now if we start evaluating at 1, 2,
Oh, you forgot to carry. Oh, no wait. Oh, the half. Fine.
and dz dy, the denominator doesn't change. It's the same. Only the top changes. We're going to do a little bit more with this problem, but I want to wait till everyone has a chance to write this down so everybody's on the same page. I really did think about telling everybody I'd finished grading the test and then going to bed. because that was just making me laugh. I was giggling so much. Everybody's waiting for the scores to get posted, and I do it the next morning. Total dick move.
Work so much. Refresh page every 10 seconds. Whole night of this.
All right, so what we're going to do is now we're going to take the mixed partial derivatives. These are called mixed partials. Because the derivative changes. Oh, I see a chat. No one ever chats, so. The notation goes left to right here. The equivalent of this in this type of notation is d squared z dy dx, which is d dy of dz dx. So we do dz dx first, and then take the derivative with respect to y. So in the notation with the d's in it, you have to recognize that it goes in backwards order. We go that direction. In terms of this notation, it goes left to right.
I'm wondering if you're asshole.
So if we're doing d dy of dz dx, this is for the problem we're looking at. That was zx right there. So we're doing d dy of that. Give you a chance to work on that, see what you come up with.
So is the pacing guide still accurate, even though we changed the,
Yeah, we just changed the order of the last 3 days. Today we are on track.
all right, yeah, same deal. All right, just making sure.
You will get a full education in Calc 3 plus some bonus lecture like the non-dimensionalization. Vanita won't give you that.
So we went 3-dimensional, and now we're just like getting rid of all the dimensions.
What?
What does that mean? Non-dimensional.
Non-dimensionalization means to take the dimensions out of an equation.
Oh, so
That's
to
what
make,
I thought, but it
to
didn't
make the
any
problem
sense.
easier by taking the dimension out.
No.
So
All
picture your physics, like picture your, it is perfect in physics world. Picture your physics problems where you've got Newton meters, there's fucking like Q thrown in there. There's some, 4 epsilon pi naught, whatever the fuck it is. There's a whole bunch of shit in there. Pulling everything out that's a unit and putting it into one single thing so it shows up in only one spot rather than having units across the board. It makes it so you don't need to focus on the units anymore. You just focus on the numbers. I'll show you. We'll do that at the end. It's not part of your grade or anything. It's just more of a bonus, something you do when you get to higher order.
The next one sounds very useful.
I have one. I want.
You can use that.
Yes, sir.
Get rope plus I got they get rope minus.
All right, so what do we get on this one when we do the first part? I'm gonna get rid of that ZX because it's distracting me. The only thing that we're really looking at is that term right there. So the X in front is not a problem. So I'm gonna have, I'll bring the power down. I'll have -1/2 X. And that goes to X squared. Maybe I should put my notation over here. ZXY. I had the -1/2 X, brought the -1/2. I still have the X. The radical or the exponent parentheses drops by a power. And then I take the derivative of the inside with respect to Y, which is 8Y. And what I'm left with is -4xy over x squared plus y 4y squared to the 3/2. Now we take a look at,
Not like a step, like step 1 and 2. Like,
Oh, yeah, Lawrence is asking what's up with the 1 and 2 that you have circled.
like steps.
that's the order you do them in. We already did one up above. Like
Oh,
one
right.
was right here. So if you're starting from scratch and you just had Z, you do the one part first. So you do the X first, which is why a big reason, well, one of the many reasons I like this notation better. The order is left to right, so you know what order to do the derivatives in. Not only do I like this better for that reason, it's also got a lot less symbols. There's a lot less writing. I don't have all these D's and shit up here. When you have it in this notation, you have to work backwards. You do the X first, then the Y. You just have to remember that. So the 1 and 2 was order, but we've already done the X in the previous step. Now we take a look at ZYX. Which means we're starting with this one right there. So it should have this, but instead of the X right here, I have 4Y right here on the other version. And now we're taking the derivative with respect to X. So the 4Y stays out there. The -1/2 comes down. I still lower that by a power. And now I take the derivative with respect to X is 2X. And you will see that we get -4xy over x squared plus 4y squared to the 3/2.
Same thing.
Yeah.
Big idea.
That is certainly no coincidence that will
This
always
is
happen.
known as Clairaut's theorem.
I
I've
made a
always
mistake.
called
I made a
Clairaut.
mistake over there.
The mixed partial orders are equal to each other for two variable functions. Oop, I put a Z right there. That should say X.
See, easy to do.
Or without the Z, it might look easier like with an F.
They're on the book somewhere.
Clairaut. It should be. It's
What?
It's I don't know if it's an M.
Later something?
Eric is wondering where Clairaut's theorem is in the book. It's at least talked about. And maybe,
It's right here.
yeah.
Maybe it doesn't say Clairaut, but that's who did it, who wrote it. It is called Clairaut's theorem. Apparently they label it in the appendix. Web Appendix L. Oh, we're not on the web, never mind. But it's in there. It's so that's again assuming it's differentiable and continuous there.
Oh, we kind of saw it. Yes, CLAIRO.
Not R-O, R-U-T.
It's
I mean-
RUT. I always spelled it with O.
Because it sounds like an O.
Yeah.
I'm pretty sure I'm spelling it right.
Alright.
Now you got me fucking second guessing myself, Brandon.
Hey,
WTF.
I'm probably just as a worse speller as you are, if not worse.
I'm a great speller.
And don't take advice.
But
from me.
apparently I'm not a great speller on this. It's not an O either. It's A-U-T.
Oh gosh, that's even new. It's like a Claire. It's like Claire. Like Claire astronaut.
Oh, man.
Oh my god, that's even weirder.
Oh, that's how you do it.
That's an I, Lawrence. That's a T.
I thought it was one.
There's no ones. There's no ones in his name.
The number one.
And this is an S. This is not a 5.
Or an integral.
And that's a U, not a V.
Exactly. Oh, that's an excellent point. Let me put a little tail on it.
Or
And this is a
union.
C.
Yeah.
This is a C, not a parentheses, Lawrence. And that's an L, not a vector that's sideways, or it's not a less than symbol either.
I know L's when I see them.
And this is an apostrophe. It's not to denote the derivative of Clairaut. It's an apostrophe. That's right, because Professor Jones is, if anything, an asshole. You guys ready for more?
Yeah, let's go.
Yes.
Let's kick it up a notch. Well, let's start with the simple thing here first. So as a reminder, since this was an issue on the test, the derivative of e to the 2x is 2e to the 2x. It's not e squared. So when you're doing this, don't do this, do that.
I feel like I know it, but I still make the mistake.
Is it like panicking? Are you panicking like during the because of the short time span?
I don't know.
It happens.
I don't even-
Mistakes happen. I'll be honest, in my doing the test in 20 minutes, I had a mistake that 3 students did not make. Many students didn't make it. The same mistake I made. I rushed something and I made a silly mistake. Mistake was repeated by others. So as a reminder, if you have the magnitude of, like, say, A, maybe we should do U1, U2, U3. I'll just do U1, U2. That's the square of each term. You got to make sure you put the squares in. I skipped that on one of my things. I just had like something like that.
Variable as a constant, Did I make that?
Mistakes happen. You guys just gotta, when they do on your test, you gotta hope you don't do too many of them. Or when you do make a mistake, you can blame it on the teacher and say the T looked like a 1.
It's not just. No, because you have Y under the last constants. We used to leave it there.
Like rule.
Yeah. And then when you take the second part of the product, get rid of it.
No, you're not doing.
Oh, yeah, okay. Oh, I see what you
Remember, it's a chain rule. We're doing the derivative of the E and then the derivative of the exponent.
I still feel that, those things. How many lives is it? Is that 4 never live?
I don't give a damn. Too many.
I've seen something, I saw a quote where it said, a mistake is only a mistake when you don't correct that mistake.
And there's X, Y, X, Y, X, Y. I mean, an RP.
It's a mistake becomes a mistake when you don't correct the mistake.
Did I make a mistake?
No.
I'm hearing mistake a lot. Did someone say steak?
I was just saying that I saw a quote that said, if you you only make a mistake when you don't correct your mistake.
Oh, I like that. I make a list of partial derivatives we can try to do.
0. Wait, if that's 0, then that's 0.
What's that?
Because the derivative is right here is 0. So it's a constant in terms of y at least.
Yeah, but when you take. Oh, I see.
And then 0 multiplied by
Yeah,
that.
But this doesn't get, this just, this entire
go by heart.
after the quote.
It's in your genes.
Because
DNA is coming out.
So all it would turn into is 3,
Oh, yeah,
just 3
that's
y
what I
squared
need.
multiplied by that. Well, you want to do multiple.
You want to go, oh, it's not why, so there's no, these are matters. This is realized, this is.
It's like
2 squared, 2 squared, and then multiply by that. Because it's,
Oh, yeah.
yeah, because it's acting as a coefficient, because it's still multiply there, yeah.
If you're wrong, just put it right there.
There you go.
Maybe the thing.
Change the stock. Change the notation.
So we're we're playing with some ideas here. Doing this mixed partial thing a few times, looking at the results, and then let's see if we can go like another step. Z with respect to y would be 9y squared e to the 2x plus 3z. And y, wy with the z would be 9y squared e to the 2x plus 3z.
So the first one's wrong then. 'Cause there's no product rule, because why does it matter? This one, because why is it coefficient?
WX.
Oh, this is coefficient.
Yeah, so that it isn't true. It
Stays there.
says that.
So let me rewind. I'm hearing a question about product rule. Let's address this because if Jericho's asking, other students might be wanting to ask and have it asked. Like when I do, let's look at WX here. I could do this as ddx of the entire thing. And we will make it a product rule. Let's do a product rule. This is ddx of y cubed times the e to the 2x plus 3z plus y cubed times ddx of e to the 2x plus 3z. I guess I don't need that one right there. There is a product rule. It's definitely a product rule. This one goes to 0 though. The derivative of y cubed with respect to x is 0. So all we have left is that.
Oh,
And the derivative of that, if we do a u sub, this becomes, if we do u equals 2x plus 3z, this becomes e to the u, and we need to do du dx
You could do the same thing with just regular coefficients.
or df du
And I'll still give it
times du dx. That's the chain rule. So that the derivative of this is just itself. Then I do the du dx is the 2, and I still have the y cubed out front. So here's df du. Here's du dx. And here's the y cubed. And then I rearrange and put the 2 in front. And that's how it came with this. 2y cubed e to the 2x plus 3z. This is, you are doing the product rule. This is Calc 1 stuff. But I went through it faster. I didn't show the product rule because if you're doing the product rule on this, you're taking way too much time. You're not getting the concept of what a partial derivative is if you're trying to do a product rule. The idea of the partial derivative is every letter except the letter you're taking the derivative of is a constant. So treat the y as a constant. Treat the z as a constant when you're taking the derivative with respect to x. I might as well rewrite this as, I could rewrite this as ddx of a e to the 2x plus b. And then the y and the z would not throw you off. Because y cubed, just like a, is a constant when it's taken with respect to x. So you can do the product rule, but it means you're not understanding what this entire thing is. I want you to wrap your head around the partial derivatives. When you're looking at a two-dimensional surface,
hey, let's go back to 2D.
f of x goes in one direction where y is held constant. Y is held, like if I've got x, y like this, y is constant when the f of x is parallel to the y-axis. And the reason why it looks curved is because the surface is curved. F of y holds x constant which means f of y is parallel to the x-axis. So x stays constant here. X equals x naught here. Y equals y naught here. It's not changing. Okay. I did this in the videos. Please watch the videos. Please. Please, guys. Because then we can focus on doing more problems in class and enhancing your overall learning if you watch them. Before lecture, not after lecture. Watch them before lecture. Like we're doing 13.4 on Monday. Please watch 13.4 this weekend. If you're not watching them ahead of time, you're defeating the point of even doing lecture videos. All right. So hopefully that clears that stuff up. When you're taking the derivative with respect to a variable, all the other variables are constants. And that was a geometric representation with the pretty picture.
So you know
When you're
that
doing
scholarship-
mixed partial derivatives and it's the same two variables, what, Lawrence?
No, I finished your thought. I was just gonna ask a question. I didn't mean to disrupt your flow of thought. Well, I guess I already did. So, so the scholarship thing that you posted this morning, I was wondering, would you be willing to do like a workshop or something like that, maybe some point this semester, or before it's due?
Yeah, we'll definitely do a workshop. I was gonna, let's finish with the idea and then I was gonna talk about it for a second.
Okay.
Notice these two, because x and y were the two derivatives, these are the same. When z and x, I did the z and x derivatives, these two are the same. And when we did z and y, these two are the same. Now, Clause's only talks about two things. What happens if we go with wxyz and maybe wzyx, where like the first two are not, like if I do z on both of these should end up the same. wxyz and wyzx should be the same, or yxz should be the same, because the first two steps were the same. But what happens if they're not the same? Let's take a look at wxyz and wzyx. Wxyz right here, we bring the 3 down because the z's the variable now. So this becomes 18y squared e to the blah blah. There we go. Here's your blah blah. That was wxyz. When we do wzyx, that's working off of this one. The x, I bring the 2 down and I've got 18y squared blah blah. Well, does this hold true if I do the derivatives of any of them? That if I do the third variable on any of them? That one, if I do the z here, the 3 comes down, I've got 18y squared blah blah. If I do it on zx, I'm doing y next. Y, that turns into the power comes down, makes that 18y squared. We still have blah blah. And wxyz, we know that's the same, blah blah. And if we do this one with respect to x, we bring the 2 down, and we've got another 18y squared blah blah. So it looks like Clause's extends to mixed partials of 3 derivatives.
What was that? Let's see. 5 months. 5 months.
Of 3 variables. But that might only be this equation. I'll have to go look it up and see if Clause extends across more than, multivariables above 2 and 3 and beyond. So it looks like it matches, and there's your use of the blah blah in the very next lecture. So the scholarship that Lawrence is talking about, that there's an announcement on, Jack Kent Cooke Scholarship is an undergraduate transfer scholarship. Jack Kent Cooke owned the Washington Redskins, and when he passed away, he left his money to education. To receive the scholarship, you need to be getting good grades. You have to get good grades. They don't have to be 4.0s, but you need to be getting good grades. You need to come from, have financial struggles in your family is always a perk. And you need to have like a goal of something you're wanting to do in life. You can't just be going, I want to go to college, but I don't know what I'm doing. If you're going to try for the scholarship, be purposeful. At least if you got to lie, stick with it. I hate saying that, but like, be more confident about what you want to do than maybe you already are, is a better way to say it. I was not 100% confident when I applied that I wanted to be a teacher, but I went that route when I applied at COS when I transferred. I got it. At the time, it was only $30,000 a year, worth up to $30,000 a year at a 4-year. It's now $55,000 a year at a 4-year. And then if you get the undergraduate transfer, it will pay for your education through the 4-year, and you are eligible to apply for the graduate scholarship they have, which is only awarded to previous Jack Kent Cooke scholars. And you will join, whoa, that was neat. What the fuck happened here? It went all full screen, some bitch. There we go. There are like maybe 7 or 8 of us in that COS in the last decade or so that have earned it. I have interviews in the announcements. You can see him last fall. Samuel Mulick, the president of SETA at the time, he was applying. He interviewed me. We interviewed another person that had received it and had discussions about it. But we can do a workshop and do more talks in person, or over Zoom or in person this semester. It opens up on October 6th. You do need to, it's like open for a month. I don't know the deadline exactly, but it's generally around a month. And you need to be transferring in fall. You don't want to apply for it if you're not transferring it next year. But it's good money. And if you're going to apply and you want help, I'm willing to help you with whatever you need. Other than that, peace. I'll see you guys. Oh, we got Starbucks this weekend. If you're coming, let me know. 8 to 10 on Saturday and Sunday.
I'll be holding my regular SIR tomorrow as well.
All right, see you, Mr. Jones.
Take care.
And that taking derivative order is right now.